Imagine waking up to a sky that looks almost normal, while something smaller than a city enters the solar system and quietly becomes the most dangerous object Earth has ever faced. No roaring engine, no invasion, no warning our instincts were built to understand. Just a dead star, passing in silence, carrying enough gravity to unmake orbits and enough magnetism to make our entire planet feel like a fragile electrical mistake. A magnetar is not large by cosmic standards. It is almost offensively small, roughly the size of a city. A sphere, only a few kilometers wide. And yet inside that tiny body is more mass than the sun. It is what remains after a giant star dies, collapses and crushes itself so completely that matter is pushed into one of the strangest states the universe allows. If you could hold a piece of it in your mind, even that would feel impossible. A sugar cube amount of neutron star matter would weigh more than a mountain. This is not a rock, not a planet, not even a normal star. It is the ruin of a star. A core so dense that the familiar world of objects and surfaces begins to feel like a lie we tell ourselves to stay comfortable. And then there's the magnetic field. Earth has a magnetic field. It is gentle, protective. It guides compasses, bends charged particles, paints auroras at the poles. A magnetar's field is in another category entirely. It's not stronger in the way a bonfire is stronger than a candle, stronger in the way a supernova is stronger than a match. Its field can be trillions of times more intense than Earth's. Ordinary language almost fails here. We use the same word, magnetism, for both. They are not emotionally the same phenomenon. This is why magnetars feel so unsettling. They are not simply heavy. They are not simply hot. They are distortions of scale. They force us to admit that the universe can compress nightmare-level power into something smaller than London or Manhattan. Then let it drift through a galaxy filled with planets that were never asked if they wanted to survive. And the strangest part is this. Earth has already felt one from across the Milky Way. In 2004, Magnetar called SGR 1806-220 unleashed a giant flare from around 50,000 light-years away. The burst traveled across the galaxy and still disturbed Earth's ionosphere. Think about that. A starquake on an object we cannot visit, on the far side of the galaxy, reached our planet and left a measurable mark on our atmosphere. It was one event, at one distance, and even then, Earth noticed. So the real question is almost too dark to sit with for long. If a flare from that far away could touch our planet, what would happen if the magnetar itself came close?
At first, close sounds vague. Space makes everything vague. A nearby star is still unimaginably far from us, but with a magnetar, distance is the whole story. A few light-years away, it is an astronomical threat. A few astronomical units away, it becomes a solar system crisis. And if it came truly near Earth, near in the human sense, there would be no clean line between disaster and impossibility. There would only be stages of collapse. Long before anyone could see it with their eyes, astronomers would notice that something was wrong. Tiny deviations in the motion of outer objects. Comets nudged out of old paths. A gravitational presence where none should be. That would be the first horror, not fire in the sky. Mathematics, equations whispering that a corpse of a star is wandering into the neighborhood. Then the panic would begin, not because people understood magnetars, but because they would understand mass. A magnetar does not need to hit Earth to destroy it. It only needs to pass close enough for gravity to start rewriting the architecture of the solar system. Planets are loyal to the sun because gravity holds the choreography together. Add another object with stellar mass, and the dance becomes unstable. If it passed through the outer solar system, Earth might still survive the first chapter, but survival would already feel different. The orbits of icy bodies would be disturbed. Some would be flung outward into darkness, others inward toward the inner planets. The calm geometry of billions of years would fracture. The night sky would still be beautiful. That would be the cruel part. Beauty would remain on the surface while the deep structure underneath it began to break. Move the magnetar closer, somewhere around the distance between the sun and the outer planets, and the threat changes from abstract to intimate. The giant planets would feel it first. Their orbits could shift, their moons could be perturbed. The solar system would become a place of delayed consequences. A slight deflection now could become catastrophe years later. In space, doom does not always arrive as an explosion. Sometimes it arrives as a new trajectory. And Earth at first might only feel the unease of systems drifting out of tune. The length of the year could change. The shape of our orbit could distort. Seasons would no longer be inherited promises. Climate would begin to behave like something startled. Weather patterns built on stable sunlight and stable motion would lose their memory. Farmers would not speak in terms of apocalypse. They would speak in terms of failure, which is how civilizations usually meet the end. Not with one word, but with many practical ones. But gravity is only the first problem. A magnetar is also an engine of high-energy radiation, not always erupting, not always violently active. But even a comparatively quiet magnetar is not a friendly neighbor. It is hot, compact, and capable of releasing intense X-rays and gamma rays. The closer it gets, the less Earth's atmosphere remains a shield, and the more it becomes a thin act of courage. If a giant flare happened within roughly 10 light years, studies suggest the ozone layer could be devastated, not by impact, not by heat you can feel on your skin, by chemistry, by invisible radiation stripping away one of the few things standing between life and the raw hostility of space. That is what makes cosmic danger so psychologically difficult. It often arrives in forms our senses never evolved to fear. Now imagine that same class of object not 10 light years away, but inside the solar system. At that point, satellites would become the first casualties. Communication networks, navigation systems, weather monitoring, global timing, defense infrastructure, nearly all of the invisible machinery modern civilization uses to feel coherent would start failing under radiation stress and electromagnetic chaos. We like to imagine the end of the world as a visible event, but for us, it would begin as signal loss. Dead screens, silent networks, aircraft rerouting, financial systems fragmenting, power grids stuttering under currents they were never designed to endure. The sky, meanwhile, might become haunted by auroras in places that have never known them. Not gentle curtains at the poles, but a planetary nervous system glowing in distress. Red, green, purple. The atmosphere lighting up because space has become too electrically violent to ignore. It would be beautiful in exactly the wrong way. The kind of beauty that makes people gather outside with phones in their hands, not yet understanding that the same forces painting the sky are dismantling the protective bubble around the world. And still, this is not the worst of it. Bring the magnetar as close as the orbit of Earth, and now the planet faces an object with roughly stellar mass passing through its immediate environment. The Sun would no longer be the only master of Earth's motion. Our orbit could be stretched, bent, or broken. Earth might be pulled inward toward greater heat, thrown outward into a longer winter, or even ejected into interstellar darkness. The exact outcome would depend on the path. That uncertainty is part of the terror. A Magnetar flyby would not give us one disaster. It would give us a lottery of disasters, all drawn from the same indifferent physics. People sometimes imagine that the magnetic field itself would instantly rip the iron from our blood or tear atoms apart the moment it arrived. Reality is subtler and somehow more frightening. At very large distances, gravity and radiation would ruin our future long before the magnetic field directly reached into our bodies. The universe does not need theatrics. It has more efficient ways to erase worlds. But if the magnetar came truly close, closer than planets should ever allow, then its magnetic field would become its own kind of violence. Electronics would fail on a fundamental level. Stored data could be corrupted. Materials would behave strangely. Induced currents would surge through conductive structures. The boundary between machine and environment would dissolve. Humanity lives inside a web of electricity. A magnetar passing nearby would remind us that all our intelligence is still built on delicate charges moving through fragile circuits. And then there is the ocean. A close flyby of something this massive would raise tides beyond anything in human history. Not waves from wind, not storm surges. Tidal deformation on a planetary scale. The crust itself would flex. Earth would be squeezed and strained. Earthquakes would multiply. Volcanoes could awaken under changing stresses. The planet would not simply be illuminated by catastrophe. It would participate in it. Land would move. Sea would rise in unnatural rhythms. Coastlines, which we treat as stable facts, would reveal themselves as temporary suggestions. At a distance comparable to the Moon's orbit, the story becomes almost too extreme to describe without sounding fictional. The tidal forces from an object of stellar mass that close would be catastrophic. Earth's orbit, the Moon's orbit, the balance of the whole Earth-Moon system would be shattered. The sky would not have time to become symbolic. Civilization would end inside a physics event. And if somehow it came even closer, then the magnetic field that seemed almost abstract earlier would finally become intimate. Molecular bonds could be distorted. The structure of matter in ordinary materials could begin to behave in unfamiliar ways. At those distances, the distinction between planet and laboratory disappears. Earth would no longer be a home. It would be material caught too near one of the universe's most extreme objects. This is the point where the question stops being, would humanity survive? And becomes, would Earth remain recognizably Earth? Probably not. That is what a magnetar really does to the imagination. It removes the comforting middle ground. Most threats still let us pretend there will be planning, adaptation, resilience, recovery. A magnetar flyby belongs to a different class of reality. It is not a crisis for governments. It is not a challenge for engineering. It is a reminder that there are scales of energy where civilization becomes irrelevant almost instantly. And yet, this is not a story about despair. Not really. Because hidden inside this nightmare is a strange kind of clarity. We spend much of human life inside local concerns, local fears, local ambitions. We argue over borders on a planet, wrapped in a paper-thin atmosphere. We build identities inside a century if we are lucky. We mistake familiarity for permanence. Then astronomy places a magnetar in the mind and quietly changes the proportions of everything. A world can be stable for billions of years and still be fragile. A species can be clever and still be helpless. An atmosphere can feel endless from the ground and vanish like a thought under the wrong radiation. The universe does not hate us. That would at least make it personal. It is something colder and, in its own way, more beautiful than hatred. It is vast enough to produce objects like magnetars without explanation, without apology, and without noticing whether anyone nearby has oceans, forests, music, or memory. But there is also dignity in seeing that clearly. To understand a magnetar is to understand that Earth is not ordinary, not because it sits at the center of anything, not because it was guaranteed, but because in a universe capable of such violence, this planet has managed for a little while to become gentle, liquid water, a magnetic field of our own, a breathable sky, creatures that can look upward and ask what could destroy them, then keep looking anyway. That may be the most human thing of all. If a magnetar passed near Earth, the answer would not be one event. It would be layers of unraveling. First, the hidden mathematics, then the broken orbits, then the radiation, then the silence of satellites, then the failure of power, then the deformation of ocean and crust, and somewhere in the middle of it, billions of people looking up, trying to understand how something so small in the sky could be so large in consequence. Maybe that is why these objects haunt us. They make the universe feel less like scenery and more like a living field of extremes. They remind us that space is not empty peace. It is structure, pressure, distance, violence, and improbable beauty sharing the same darkness. And still we study it. We send telescopes into orbit. We measure strange pulses from dead stars. We name the monsters. We turn terror into knowledge, not because knowledge makes us safe, but because it makes us honest. It lets us stand for one more moment between ignorance and awe. So when we ask what would happen if a magnetar passed near Earth, we are asking more than a physics question. We are asking what it means to live on a small, temporary world in a universe that can create both consciousness and annihilation from the same laws. We are asking how precious ordinary mornings really are, how miraculous a quiet sky is, how rare it may be for a planet to spend millions of years not being interrupted by something catastrophic. Tonight, the Earth is still here. The atmosphere still holds. The oceans still obey the moon we know. The stars above us look calm, even the dangerous ones. And somewhere out there, objects stranger than fear continue moving through the dark, carrying their unimaginable fields across distances so vast they barely fit inside thought. That does not make our world meaningless. It makes it sacred in the only way the universe seems to allow. Not eternal, not protected, just astonishingly, briefly alive. If you felt that scale with me, stay a little longer. Like, share, and subscribe, and we'll keep following these quiet cosmic questions to the edge of what the night can reveal.